Hey guys, how we doing? I think what we're going to do right now is we're going to take what we've learned from that last quadratic function that you were given, and we're going to try and apply it in a real world situation. We're going to take the different pieces of that projectile motion equation that you just went over, and we're going to read through and try and pick out the important parts. So in this situation, we have a toy rocket, which is fired vertically into the air from the ground at an initial velocity of 80 feet per second. So when it takes off, you light that fuse, it's leaving at 80 feet per second. And we want to know how long will it take for the rocket to return to ground level. Let's look at the things that we know. All right. So I'm looking right away and I see that velocity term. So I recognize that right away and I see, okay, so 80 feet per second. And that's got to be my velocity. So I'm going to plug that in right here. I'm going to say, well, that's got to be my 80. So I'm going to plug that in right here. I'm doing the best I can to write with my mouse. Um, and I also see something that's important too, is I see find the time, right? So find the time. That tells me that if it says find the time, if that's what I'm looking for, that must be what I don't know. So I'm going to put a little question mark there because that's the part I don't know, which means I got to be able, we already know this. We learned from linear functions, from exponential functions, and now from quadratics. You can't solve for more than one variable. So we got to be able to identify the h and we got to be able to identify the s. So if we remember, let's jump down to the S because we know that the S is the initial or starting point, right? It's the beginning. And what I want to do is let's read through this and figure out where is the rocket before we even start this process. A toy rocket is fired vertically into the air from the from the ground, right? And we'll even pick another color, right? So from the ground. If it's firing from the ground, what does that tell us? Well, it tells us the initial height has to be 0, right? It's on the ground already. So we know that that's got to be 0. And the lastly is we want to know where it ends. And h we know is our height, or in this point, where whatever period of time we're talking about. But since we're looking for the time, then we must know what the height's going to be. And we're going to look for another clue here that says find the time it will take for the rocket to return to ground level. Well, if it's returned to ground level, what must its height be? Right, it's hit the ground again. It's got to be at 0 as well. So let's take a look at this one. That being the case, we now can fill in our function. So I'm going to go ahead and go back and we're going to type this all in. So I want to know when 0 is equal to negative 16t squared, and that all, plus 0, or plus 80 rather, 80t plus 0, which is our initial height. So we've got that. So this is the equation we're going to work with, right? So we've got our quadratic here, and we're going to try and figure this out. So let's go ahead and do that. Right off the bat, I don't need this anymore. So I'm going to go ahead and write in. So I want to know when 0 is equal to negative 16t squared plus 80t. The next thing I want to know is what is it that I can factor out of this? We see that quadratic, we see it set to 0. We want to be able to factor this and see if it's possible that we can find that solution here. So we want to know when 0 is equal to, so what goes into both 16t squared and 80t? Well, the first thing we should be able to see is that both of them has a t. So there's got to be a t in both of them. So how about 16 and 80? Well, I know that 16, 8 goes into 16, 8 goes into 80, but if I break out my little calculator and look and I say, whoa, look at that, 16 actually goes into 80 as well. So what I'm going to do is I'm going to factor out a negative 16t and see what's left. Well, if I were going to redistribute this again to get negative 16t, I'd have to multiply negative 16t squared. I'd have to multiply negative 16t by just t. And I'm factoring out a negative. So if I factor out a negative from that positive, it means minus And then 16, as I just did on my calculator, 16 goes into 85 times. So that means that to find out what t is, I have two roots. Just like we know on a parabola, we have potentially we have two solutions. We have two of them here. And so we're going to start off by saying, well, I know this thing becomes zero if either if this is zero or this becomes zero. So I'm going to set them both up. 0 is equal to negative 16t, or 0 is equal to t minus 5. So in one case, right off the bat, I know that this becomes 0 simply if t is equal to 0. So if t, because 0 times negative 16 gives me 0. So we know that t has to be equal to 0. And then I can also add 5 to both sides on this side. I'm going to try this one out, plus 5 and plus 5. And I find out that in this case, t is equal to 5. Now, the cool thing about this is I've got two solutions, and the reason is this is why I love quadratics, because there's such a real application to them. So you got to ask yourself, why is it? So how is the rocket on the ground twice? It says it hits the ground 2 times. Well, right, at 0, because we haven't even started. Because remember, where did that rocket start? It started on the ground. But then it went up in the air, just like with that parabola. So we have our little picture here. Here's our rocket, right? There's our little rocket ship. And it takes off. And hits the ground. And there's the rocket, like, kind of lying on the ground like that. And this is at 0 seconds. And this is at 5 seconds. So the 2 times it hits the ground is before we even started, and then when it hits the ground again. All right? We're going to try one on your own now.